Hello, and welcome to this Earth Engine training. I'm Tyler, and along with three of my colleagues, we're going to be walking through the basics of getting started with Earth Engine, starting with an overview of the Earth Engine platform itself. This is mainly geared towards people that are just getting started with Earth Engine, but even if you're an experienced Earth Engine developer, we expect there's going to be some tricks that you're going to learn along the way. The first segment is going to be Nick, who's going to give an overview of the Earth Engine platform itself. The second segment will be Justin, who'll give a description of the Earth Engine data catalog and where you find the data that you're going to be using for the analysis. Next up will be Gino, who'll be giving an overview of the Earth Engine Code Editor, which you can use to develop JavaScript algorithms for Earth Engine. And then finally, I will be back to give an overview of Colab notebooks and how they can be used to work with Earth Engine in the Python API. The segments are pre-recorded and they'll be available after the meeting. But if you're watching this live, you can use the platform's chat features, probably down below there, to ask questions as we're going along, because we'll be watching it as well with you. All right, so let's get started.
Hi everybody, I'm Nick from the Earth Engine team, and in this short video I'd like to give you a broad overview of Google Earth Engine. Let's get started. In its most general sense, Earth Engine is a geospatial processing service powered by Google's cloud, and we have some specific goals for this. First, we want to provide a tool that will let you visualize and do computations on very large geographic data sets from local to global scales. We'd also like to use Earth Engine to make substantial progress on global environmental problems that involve large geospatial data sets. And you can learn more about Earth Engine from this link. On all the slides that I'm going to show you today, I'll have some links at the bottom to docs where you can get more information. Often we get asked the question, why is Google doing this? And the reason is that it's part of Google's mission to organize the world's information and make it universally accessible and useful. So we see Earth Engine as like the geospatial manifestation of this mission statement. What is Earth Engine? There are a bunch of components, and we'll do a deeper dive into each of these, but at its core, Earth Engine is a large collection of geospatial data sets, which we call the data catalog. Co-located with the data catalog is compute infrastructure, so a large cluster of machines that we make available to all Earth Engine users so that you can analyze and compute and visualize the data that's in the catalog. To do that, you also need APIs, and so we provide a JavaScript API, a Python API, and a REST API so that you can implement your geospatial workflows in Earth Engine. We also provide interactive apps that let you display the results of your analysis. So if you design an algorithm that you're very proud of, you'd like to share it with your friends and collaborators or the world, you can build an app that will let any user see the result of your analysis. As I mentioned a second ago, the core of Earth Engine is really the public data catalog. There's a lot of information in here. There's all of Landsat, all of Sentinel, most of MODIS, terrain, land cover data, weather and climate data, and of course much more. And to discover what's in there, you can search the data catalog. So here's a link that will take you to some pages that describe what's in there and let you search for the data sets that might be important to your analysis. There are a few ways to connect to the Earth Engine service, and most users choose to start with JavaScript if for no other reason because all our docs are written in JavaScript. But we also provide the online code editor and interactive development environment that lets you easily prototype your algorithms, and you can learn more about the code editor in a later video. If you're a Python programmer, you can also use Colab, and Earth Engine is installed by default in the public Colab kernel. So all you have to do is import it and start writing Earth Engine code. The Python and the JavaScript are nearly identical, so if you learn the Earth Engine JavaScript, you'll also know the Python. If you don't want to use one of the client libraries, and we'll talk more about that in a second, you can also make REST calls. So we provide a REST API so that you can make authenticated HTTP requests directly to the Earth Engine servers without going through one of the client libraries. Finally, once you've prototyped your algorithm and scaled it to your area of interest, you might want to share the fruits of your labor with the world, and you can do that through these EE apps. You can build apps with user interface components provided in the Earth Engine library, and the app will be hosted by Earth Engine for anyone on the internet to see, or you can restrict it to a specific group of users. What can you do with Earth Engine? Lots and lots of good stuff, including visualizing your data at local or global scales. You can do that on a map. You can make charts or even little videos or animations out of the data that you find in the public catalog, or that you can make out of the data in the public catalog. And you can make data by doing computations on images or on features, and we'll talk more about that. There is machine learning capability in Earth Engine, and Earth Engine can also connect to TensorFlow. So if you build your machine learning pipeline in TensorFlow, Earth Engine can connect to that model, and you'll be able to see the results on the map. You can do image segmentation, neighborhood operations, time series analysis, and develop the interactive apps that I talked about previously. And you can download data from the data catalog or data that you compute, and you can upload your own data into your own private repository. And we'll talk a little bit about each of these steps in the following section. First, visualization. Here's a really nice visualization of annual NDVI in Africa done by my colleague Justin Broughton, and you can find his tutorial online from this link at the bottom of the screen here. You can do per pixel computations. So in this diagram, this is just a multi-band image, and here's another multi-band image, and if you add them together, Earth Engine will perform that computation pixel-wise. But there's not only addition, there are many other mathematical operators and expressions that you can use, and see the link at the bottom to learn more. Compositing is a very common workflow in Earth Engine. And by compositing, I just mean aggregation over a stack of images or a stack of bands or a time series, if you will, or if these are chronological images. And we call that a reduction because you're reducing many images into one. And this is just an aggregation pixel-wise over a stack. Aggregation over space is something that we call a spatial reduction or a reduce region in Earth Engine language. So here's a little region, here's an image. You want to overlay the region onto the image and discover the mean of pixels in that region or standard deviation or something. So that's a spatial reduction, and then you just get your answer, which in this case is 42. Machine learning. Sorry for the code here. You don't have to understand this, but I just want to let you know that there is an EE classifier package that has classifiers and regression algorithms in it, such as random forest, and see the docs to learn about the other classifiers that are in there. But all you have to do for machine learning in Earth Engine is instantiate the classifier, train it with some training data, and then classify an image with your trained classifier and display it on the map. And learn more about the other algorithms and how to do machine learning in Earth Engine from this link. Earth Engine is a little different from other geospatial softwares you may have used in the past because scale and projection are much more flexible. Specifically, in Earth Engine, scale and projection are determined from the output. So if you're using something like the Code Editor, the projection is set by the map display, which is Maps Mercator, and the scale is set from the zoom level. You might also set scale and projection in, say, a reduce region call or an export call. But all those are outputs to the process. So that's how you are able to mix up images of different scales and projection. And when you specify the output, Earth Engine will go and get all the inputs at a consistent scale and projection and do the computation that way. How do you do all this good stuff? Earth Engine provides this client library, which has a variety of EE objects and methods in it. So for example, a raster is represented by an EE image, and you can do things like the example I showed you previously. You call .add on this ee.image, and you can add another image or multiply or divide, so on and so forth. A stack of images is an ee.image collection, and you can do things like the compositing that I was describing earlier. In this case, it's just a median composite in each pixel. EE.feature is Earth Engine's representation of vector data. So a feature contains a geometry and a set of metadata properties, and you can do things like compute the centroid of the feature. A collection of features is a feature collection, and you can do things to that collection by doing something like calling .map. And inside here is a function, and you'll learn more about how to write those functions later. But that is how you do something to every element of a feature collection, or an image collection for that matter. You would map a function over it. And you can learn more about that in our Get Started guide. It's important to note that those EE objects are in fact just handles for objects on the server. So what happens is when you write some code in one of the client libraries, it turns that code into a JSON request object, which is then sent to Google to Earth Engine for processing. And on the server, the data that you've asked for are loaded and the computation that you've asked for is performed. And then the result or the response is sent back to your client. So here's a computer and you've written some code here. The request is sent to Earth Engine for processing. The response comes back to your computer, and then you can display it. The response might be a number, it might be a chart, it might be a display tile. But the point is that this is a fairly low bandwidth operation, and that lets you prototype very large operations without relying on your own computer to do all the computation. The other important thing to note about Earth Engine objects is that in fact they are just handles for something on the server, and therefore you can't mix them with other third-party libraries. For example, EE image does not work with scikit-learn. You need to use Earth Engine methods for Earth Engine objects, and you can learn more about that in this client and server link. There are two computation modes for Earth Engine. There's an interactive mode and there's a batch mode. In the interactive mode, you're using your own computer and you're getting results back interactively. The problem with that is that there is a 5-minute timeout, and so very long-running computations will not work in interactive mode. So interactive mode is useful for prototyping your computation, and then when you want to run it at scale over more data or a larger spatial area, you would do that in batch mode. And that generally means exporting something in Earth Engine. So when you export your computation, you're materializing its output. It might be an image or a table or something like that. But the difference is that when the server gets your JSON object, it gives you a different execution environment. You can use more memory, your computations can take longer. Earth Engine will apply many machines to the task, and when the result is done, it will be in your Earth Engine assets folder or a Google Cloud Storage bucket or in your Drive account. So to summarize, interactive mode is what you would be using in, say, the code editor for a fairly simple computations to prototype your analysis. And when you're ready to scale it, you would do that in batch mode with one of the export functions. So to get started on all this stuff, first you apply for Earth Engine at this link. Please do read the docs where you can learn more about everything that I've just talked about. And in the meantime, happy coding.
Hi, I'm Justin, a technical writer for the Earth Engine team. In this segment, we'll be exploring the Earth Engine Data Catalog. The Data Catalog is a public archive of over 700 geospatial datasets made available through the Earth Engine API. Major dataset categories include imagery, climate and weather, and geophysical. Auto-ingestion pipelines are continuously updating and adding new observations to the archive. Some datasets, such as GOES, Sentinel, and Landsat, are ingested in near real time, while others are updated periodically as new data are made available by providers. Catalog entries and their metadata are accessible via a website. Let's take a look. Welcome to the data catalog. You can find the site URL provided in the video description, but I often simply do a web search for Earth Engine Data Catalog. You can also access it from the JavaScript Code Editor's search bar menu, selecting View Data Catalog. You can also get there from the Earth Engine Developer Guide pages using this Data Catalog tab. With over 700 datasets, discovery is an important function of the site. There are several ways to find data of interest. There are easy access points for broad categories of data, such as those shown here on the home page. Clicking any one of them takes you to a page of relevant datasets. There are also dedicated pages for Landsat, MODIS, and Sentinel. You can browse by tags, search for keywords and phrases, or simply view all datasets using this tab or this button. Let's look more closely at these options, starting with the broad categories here. Suppose you're interested in terrain datasets. Let's explore elevation. These pages are showing you the results of filtering the catalog by a tag. See that the active tab has changed from the home page to the Browse by Tags page. What you see here are cards representing these data sets with a title, a thumbnail, a description preview, and list of available tags. From this page, we can filter these data sets further. Let's try LiDAR, for instance. And we see that we've reduced the collection down to 4 from many. You can also click on tags to filter the collection. Let's try Australia. You can see a full list of tags by clicking Browse by Tags. And here again, we can filter by tags, which is helpful given how many there are. Let's try sea surface temperature. We see there's 8 data sets. We can try evapotranspiration. We see that there's 6 data sets. How about forest disturbance? Nothing. Well, in this case, we could try to search for keywords and phrases. And we will search all results in the Earth Engine Data Catalog. And now we see that there are a number of data sets whose descriptions include the word forest and disturbance. Let's take a closer look at a dataset's metadata page. Let's go to Landsat, Landsat 8, and select Surface Reflectance Tier 2. Each dataset in the catalog has a page that looks similar to this, that includes a thumbnail representation, dates of availability, a provider's link, a code snippet to import the collection or image or feature into your Earth Engine script, and a list of tags. It also includes tabbed sections for a dataset description, the bands that are available, and these names are important. They're used in the script to select data in your algorithms. It also includes the image properties associated, which are important in your scripts for filtering images by metadata. At the bottom, we find an example of code to import and visualize each dataset in the code editor. You can copy and paste this into the code editor or simply click this button, which will take you to the code editor. And if you hit run, it will evaluate the code and provide a visualization. Well, that concludes this segment on the Earth Engine Data Catalog. If you find that there's an important data set for your work that's unavailable, please let us know by filing a data request. You can find instructions in the video description. Happy coding!
Hi, I'm Gino Michelli, and I'm a Senior Developer Relations Engineer on the Google Earth Outreach Developer Relations team. In this segment, I'll be taking you on a brief tour of the Earth Engine Code Editor. The Earth Engine Code Editor is an interactive development environment, or IDE, where you can write, run, test, and share your own Earth Engine algorithms using the popular JavaScript programming language. The code editor runs right inside your web browser, so there's nothing to download or install. That means you can start creating your own Earth Engine scripts and analyses right away. Let's get started. Once your account has been registered, as discussed in previous segments, you'll be able to access the code editor from your browser at code.earthengine.google.com. When you first open the code editor, you'll notice the interface is divided roughly into 5 areas. The header area contains a search box for finding datasets and places, as well as helpful links to documentation and community forums. It also includes links to provide feedback and to request new datasets. In the panel on the left-hand side, you can find all of your own Earth Engine scripts and personal assets. From here, you can also quickly access helpful documentation and examples. Front and center is the editor panel, where you'll write your actual code. In the panel on the right-hand side of the screen, you'll find several useful tools. Here you can print text, charts, inspect pixels on the map, and manage long-running tasks. Finally, the map at the bottom of the page is where you'll visualize raster and vector maps. It's also where any custom user interfaces created by your scripts will be shown. Let's dive deeper now into each of these sections, starting with the left panel. You'll notice the left panel consists of 3 tabbed sections: Scripts, Docs, and Assets. The Scripts tab lists all of the Earth Engine scripts you have access to. This includes your own scripts, scripts other Earth Engine users have shared with you, as well as useful example scripts covering a wide range of topics. The scripts shown in the left panel are stored in repositories, which in turn may be further organized into folders. In addition to being accessible from the code editor, each repository is accessible using the popular version control system Git. Earth Engine repositories may be cloned and manipulated using Git outside the code editor. Repositories and folders, of course, can also be created and managed directly inside the code editor. You can click the red New button to create a new repository, folder, or file. To change the settings for a repository, click the gear icon that appears when hovering over the repository's name. We'll come back to this in a second. The second tab, the Docs tab, provides a quick reference for all of the Earth Engine API classes and methods. Type the name of a class or method into the filter box to view what each method does and what parameters it accepts. The third and last tab, Assets, is where you'll find any images, feature collections, or tables you have saved. Clicking the New button, you can also import your own data. These assets can be used by your Earth Engine scripts, shared with specific users, or made public, depending on your needs. Moving up now, back to the page header, you'll find the search box. As its name implies, the search box lets you quickly search for raster, vector, and table datasets in the Earth Engine data catalog. You can also quickly import a dataset into your script by entering a part of its name and clicking Import next to the desired result. You can also click the magnifying glass button to get more information about each result. For this example, let's import the SRTM Digital Elevation Data version 4. You can also use the search box to center the map on a specific place. Just enter the name of a place and click a result to pan the map to that location. Moving down to the editor pane, you'll notice some code was added when we imported the SRTM dataset. So in addition to allowing you to easily import and manage assets in your code, the editor provides some pretty useful code highlighting and basic autocomplete functionality. One way to activate the autocomplete feature is to type the part of a name of an Earth Engine object or method, like map, dot, for example, and press Control Space. A list of available methods will appear right in line, together with relevant documentation shown in the tooltip. It's worth noting that some of the options of the code editor can be adjusted or tweaked by clicking the gear icon that appears above the code editor. From there, you can adjust autocomplete behavior and which warnings are displayed as you type. Now, once your script is fully ready or just ready to test, click the Run button or hit Control-Enter to kick it off. You can see that your script was executed and the results are displayed in the map, the bottom of the page. To clear the map and any results that appeared as a result of your script executing, you can click the Reset button next to the Run button at the top of the editor. To save the new script to your Earth Engine repository, click the Save button, give your script a name, and click OK. Earth Engine provides several ways to share your code and applications with others. The Get Link button allows you to quickly share a snapshot of your script with other Earth Engine users. When clicked, a link is automatically copied to your clipboard. Changes to your script won't affect what users see when clicking this link. They'll only see a snapshot of your script taken when the Get Link button was actually clicked. This feature is especially useful for sharing code with others to get help while debugging. Another powerful tool for sharing your applications can be accessed via the Apps button. Earth Engine apps let you turn your Earth Engine scripts into hosted web applications that can be shared publicly. Clicking the Apps button will display the Earth Engine apps dialog. From there, clicking New App, you'll be prompted to enter several details about your app. Here you'll enter the name for your app, and you'll be asked to provide an existing Google Cloud project or to create a new one. Optionally, you may also set access restrictions for your app so that only members of a specific Google group can open and see your app. If you'd like your app to be featured in the public apps gallery so that everyone can find it more easily, you can also set that up here. Lastly, you may decide whether you want users to see a snapshot of your app or whether the latest code should always be used. Click Publish and your app is ready to be shared. Another way to share your scripts is to share an entire repository with specific users. As we mentioned earlier, hovering over a repository in the left panel causes several options to appear. Click the Configure button as indicated by the gear icon to open a dialog where you can specify which users may read from and write to your repository. At the bottom of the dialog, you'll find a link to your repository that will only be accessible to the users you've chosen. Moving on from the editor and left panels, to the far right sits another panel divided into 3 tabs. The Inspector tab lets you peek at data on your map. Click to activate the Inspector tab and click a point on the map to see information about a pixel, its coordinates, the value of various bands, and metadata about any imagery shown at that location. The Console tab is where errors or warnings are shown. Using the print command, your scripts may also output text, images, and even charts in this area. Lastly, the Tasks tab is where you'll find updates on long-running tasks, such as data exports to Google Cloud Platform or to Earth Engine asset folders. The last and most prominent panel is the large map at the bottom of the screen, also known as the UI root. As we've seen earlier, this is where raster and vector maps are displayed. Here you can interactively pan and zoom to explore your results. Your scripts may also add custom user interface elements, which will be displayed in this area. Buttons in the top left corner of the map let you draw and edit your own custom points, lines, and polygons, while the layers, map, and satellite buttons in the top right corner allow you to adjust which map layers are displayed and how. From here you can control the transparency and appearance of each layer, or hide layers as necessary. You can also control which base map is displayed, selecting from street maps, terrain maps, and satellite base maps. Well, there you have it. In this segment, we've taken a short walk through the key features of the Earth Engine code editor, including how to find and import datasets, and how to write, execute, and share your code. We've also seen how you can easily manage and debug your own scripts. Happy coding!
All right, I'm Tyler, and in this video segment we'll be exploring Google Colab notebooks and how they can be used to access Earth Engine's data and analysis capabilities. So let's get started. First off, what are notebooks? Notebooks are a standard format that is part of the Jupyter Project's open standards for interactive computing, and they are widely adopted in the data science community. Notebooks promote the idea of literate programming, which combines computer code with contextual descriptions such as formatted text, images, equations, hyperlinks, etc. The code in the notebooks is live, meaning that it can be interactively run to produce rich outputs that live within the notebook. Notebooks can also be used for open, reproducible science. They provide a compelling mechanism for the easy sharing of these ideas. Notebooks also can provide access to Python packages. There's a wide variety of these Python packages that are available. Packages can process data that's returned from Earth Engine, opening up many new possibilities for analysis and visualization workflows. However, it's important to note that Earth Engine backend servers do not know anything about Python or JavaScript, so you can't send arbitrary Python code like NumPy, scikit-learn, to the Earth Engine servers. Rather, you need to build your own algorithms with the objects and methods that Earth Engine client libraries provide. Notebooks can also support workflows that integrate multiple external services. Notebooks can be used to interact with online services such as Google Cloud Platform products, Compute Engine, BigQuery, Dataflow, AI Platform, etc., and pretty much any other web service that provides a publicly accessible web API. So why Colab? Well, because notebooks have become so popular and because Jupyter Project's open standards, there are many different environments for working with notebooks. And Google Colab is just one of these environments. Colab is a cloud service. It's always accessible, and you can just access documents by pointing your browser to a URL. Colab's features allow for easy collaboration. You can share your data on Google Drive or GitHub. That includes both the data and the notebooks, and you can also exchange these files with your local computer. Colab notebooks can be a great environment for communicating technical ideas that involve code. So to demonstrate this, I'll be using Colab document to introduce you to Colab. We're going to start by going to colab.research.google.com. And when we go to this URL, it brings up this web page that has a dialog box allowing you to select examples of Colab notebooks, recent notebooks you might have edited, or notebooks that you have stored on Google Drive or GitHub, or finally ones that you upload from your own local environment. But in this case, we're just going to click on New Notebook, and this is going to create a brand new notebook with no content in it. It's pretty blank here, and we can go ahead and add some code and text cells if you wanted. But to shortcut this along, I'm going to just open up a notebook that I have previously populated so we can see what it looks like here. So let me copy and paste that. And this is the way that you can share notebooks with others. It's just copying and pasting that URL. And if they have permission to open that document that you've given them using the share dialog box, they'll be able to open and work with the notebook just the same as you. Alright, so the notebook here has a series of cells on the side here. The first cell that we have here is a text cell, which has a little bit of information about the notebook itself, and interesting enough, a hyperlink here that's automatically generated. If I double click on the cell, it's a way to edit the content of the cell. And in this case, it's just a series of basic text, and at the end, there's a URL that Colab recognized as a URL and formatted it accordingly. And if I click on another cell outside of here, that one gets rendered. The next one down here is also a text cell, but if I click on this, it has a little bit of formatting markup here. It's got this little pound sign, which means that it's a first order heading. Colab uses Markdown as its styling language. So in this case, this single pound is a top level heading, and the next one down here, if I double click on that and explore it, it's got 2 pounds being a second level heading. Now these headings are really useful to use in Colab because they populate the table of contents over here on the left side, which you can collapse and expand as needed. And this table of contents allows you to skip around to different parts of the notebook. So I could skip down to basic example, to the Earth Engine basics, etc. It's nice for organizing your content, and it can be a quick way to jump around if you're trying to reach different parts of your notebook. All right, moving down a little bit farther, there's another text cell, and finally we get to our first code block here. And those are formatted a little bit different, or styled a little bit different, with a gray background and a little run button here. I can run this cell by clicking on this play button. There's a few other ways to run it as well. You can actually do it from the menu by saying run the focus cell. Or there's even a shortcut, which I really like to use quite often. And that's usually the fastest way to move through the notebook as you're doing this. All right, so I've run that cell, and after I've done that, it'll have a little indicator on the cell itself of the order that it was run in. So this is the first cell that was run, so it has a 1 there. Next we have another text cell here that's showing off a little bit other annotation type. That in this case we have some mathematics. You can edit mathematics using MathJax and LaTeX as a formatting language here. So you have to usually look up basically what the rules are of formatting that, but it's a standard language and allows you to get mathematics into your notebook as well. And finally, we have one more code cell here. It's going to take actually variables that were set in the first code cell and then make use of those to print out an output here. So one thing that you'll notice already is that you're able to interleave this code or annotations of the code with the code itself. And in the background, Colab is connected to a virtual machine that is running a Python kernel, which allows variables to be updated and propagated throughout the notebook. You can get some information on that virtual machine up here by rolling over here. It tells you how much RAM is available, how much disk space is available on here. Colab's virtual machines are transient, meaning that if you go away for a while, it might get recycled and you have to request a new one. So you can't, if you're doing something over a long period of time, you have to make sure that you're saving your work somewhere where it's not just going to be recycled with the virtual machine. All right, moving down a little bit farther. By default, you have a lot of the standard Python packages and a few extra packages that the Colab team has installed into the virtual machine. But if there's a Python package that you want and is not available, you can install it by using commands like this. In this case, it's going to run a shell command that's going to install using the Python package index, pip install xkcd. We're just going to use this as an example one of installing to show you what it looks like. Alright, so it's going to reach out and pull the xkcd package into this virtual machine and install it. It says it's done so successfully. And then once we've done that, we can actually run the next cells that are going to import the xkcd library, for example. I'm going to import a few other ones, these IPython display methods, HTML and image, because they're useful for displaying some of the results that we're going to use here. Okay, now next, this cell is going to actually make use of that xkcd object that has been imported, and we're going to use a method in here called getRandomComment. And if I click on that box and I roll my cursor over the method here, getRandomComment, it's going to give me some information about the definition of this method. So if I roll over there once again, I get a little bit of help information about this method that's there, what it does. And if I do the same thing going over the xkcd, it'll give me information about that level of object, or in this case, the module xkcd. So it's really nice to get that context-specific help as you're going along. Anyway, I'm going to run this code, which is basically going to request a random comic. And when that comes back, it prints it out. And this comic object basically says the comic is for a certain link, and I can click on that if I want, and it will bring me out to the xkcd comic strip for some random comic here. Alright, so if I go back in, I can do a few other things with that comic object. In this case, I'm going to request the get image link. And let me show you one neat thing here, is if I get rid of that method right there, and I put my cursor at the end of an object, and then I start typing, like, what are the methods here, it's going to give me a list of all the different ones that are the one I wanted. Alright, so in this case, I got the image link, and there it comes down below there. Alright, Next thing I have down here is a little cell here that is just going to print out a little bit of information. You can actually make these code cells so that they hide information, so it's only displayed when you actually run it, which can be useful if you're trying to use it in like an educational setting, asking a question that you want the student to work out before they see the answer. All right, the next section that I wanted to show off here shows an additional rich text element, the iframe, so that you can display other web pages within your notebook. So in this case, it's got a bit of code that actually has a URL for Google Slides deck. And so we have the URL there, and we're going to display that in an iframe, and below that HTML information on where it came from. So let me run that, and this populates up a thing here. Let me close down the navigation here so we can see it all. And in this case, we have a slide deck that I was using earlier. And I was going to use this to talk about, how the Colab goes through the Python client library, and it's equivalent somewhat to how the JavaScript client library works here. All right, so that was a brief overview of Colab notebooks, how they work in general. So let's get into now a little bit of how they can work with Earth Engine. So I have a new section down here, Earth Engine Basics, and get my navigation back up there. And starting off with this, we're going to import a few libraries that are useful for working with Earth Engine. The first one is the Earth Engine Python library itself, the client library, or import EE. And then another one, which is Folium. Both of these libraries are non-standard for Python, but they are installed in the Colab virtual machine. So if you're running this code in some other Jupyter notebook environment, you might have to install both the Earth Engine API and Folium before getting this to run. So let me run that down here. And so we've imported those libraries, and now the first step that you always do with Earth Engine is to authenticate yourself to the backend servers to actually show that you have access to Earth Engine. So here I run EE authenticate. It gives me this set of instructions and a hyperlink here that I can use to complete this OAuth workflow. So you select the account that you're using. You read through and agree to certain permissions. In this case, it wants to view and manage my Google Earth Engine data and manage my data and permissions in Google Cloud Storage, which means that we can use it to actually write data to Google Cloud Storage, like tables and images and things like that. So I'm going to say allow. This gives me back a one-time use password that I can copy and paste back in here. And hit return. And then this one-time use password basically gets converted into credentials that allow this virtual machine to talk with Earth Engine. Anytime the Colab virtual machine gets recycled, you're going to have to go through the same flow again because it loses all the information about knowing that you can connect to Earth Engine. All right, after you have authenticated, next step is to actually ask the Earth Engine client library to reach out to the Earth Engine backend servers and find out what it can do today. So it returns a list of all the objects and the methods that the Earth Engine backend can make use of. So it changes kind of on a weekly basis sometimes. All right, the next thing that we have down here now that we've got set up with Earth Engine is we're going to go through a little bit of the analysis. We're going to first define an Earth Engine object, and one of the most common ones to use in Earth Engine is an image object. In one of the earlier segments, we went through how you can get these image IDs for different assets that are in the Earth Engine data catalog, and I'm going to just use this one, USGS SRTM, for a DEM that's in there. It's one of the basic ones. It's one of the simplest images that we have in there, that it basically has one band elevation. So it's pretty easy to use as a starting point. So I'm going to declare this Earth Engine image object with that ID, and now it's stored in a variable called DEM. I can print out information about that object by just using the print statement, and in this case it prints out the metadata for the object on the client side. So it's saying that it's an Earth Engine object and it has a certain ID that I passed in, and that it should load up the image according to that ID. So this is on the client side. It actually knows nothing about the data or what the image even looks like at this point. You have to send it off to the Earth Engine backend servers, and there's a variety of ways to request data from the Earth Engine backend servers. One of the most common is this get info call that you can apply to an object. So we're basically saying this Earth Engine image object called DEM, let's get the information on it. And as I run that, it's going to return a Python dictionary that has quite a bit of information in here. It's got, information on the bands. In this case, it's a single band called elevation. Also has metadata on the image itself, who the provider was, some visualization parameters that you might use to get started, etc. Any of this stuff in this Python dictionary you can use in your Colab notebook as you go along, so you can use the metadata in your algorithms. Alright, the next section here goes over how to display this image in the notebook itself as a static image. So if you're familiar with the code editor, you've probably seen these visualization parameter sets before. In this case, it's a Python dictionary, but it's going to define what bands we're going to display, the min and max range of what will be considered to be the upper and lower bounds, and then a palette of colors. And then I'm going to call basically this visualize method that takes all of these parameters and whatever the image object is and produces a 3-band representation of an RGB representation of it. And that can be displayed in the notebook itself. So let me run this. It's going to reach out and get that global DEM representation of it using these visualization parameters. And that gets printed on the screen here. It's a static image. It's either a JPEG or a PNG, depending on how you requested it. And you can't really do much with it. It's just, it's a good representation of it. But a lot of images in Earth Engine are really detailed, and you want the ability to interactively kind of work with them. So the next section here is going to go through how to display an interactive map in a notebook. And this is going to make use of the Folium package, which is based on the leaflet JavaScript library that's available in Colab, this Folium package. But in order to use it, we have to basically teach it how to display an Earth Engine layer. So I have a cell here that defines a method here that adds an Earth Engine layer to a Folium object. And then once I've defined this method, I'm going to add it to the Folium map object here on this line. So this is sort of teaching it how to display an Earth Engine image. Once I've taught it how to do it, I then can go down and make use of that in the next one here. Looking through the code here is like I'm going to create a Folium map centered on a certain lat long and a certain zoom level. And then I'll add that Earth Engine layer to it, doing a little bit of manipulation here just to make the oceans look a little nicer. I'm basically going to mask out the stuff that's less than 0. And this makes a interactive map that you then can zoom around in. And I always like to check things out by going to the Grand Canyon, because I just like the way that renders. But this is the basics of how you can get your Earth Engine data, your tiles of an image object into Folium. And Folium is a full-featured mapping package that you can add all kinds of other layers as well to it. Alright, so that's the basics of how you get through here. Oh, I see one thing that's over here on the side, which I forgot to clean up from one of my previous runs here, is a comment. When you are using the Colab notebooks and you're saving them on Google Drive, you have some neat collaboration features that I was going to discuss down here below, but one of them is the ability to comment. So you basically can leave comments for any collaborators that have access to it. Something like this, and whoever else is opening up this notebook and looking at it will have access to the same comment features that you have here, and you can resolve and have a little discussion about your notebook and your code within here. Alright, so that's comments. That is when you're saving this information on Google Drive. But there's other ways that you can save notebooks as well. You can save them to GitHub either as a short GitHub gist, just a very small single file, or you can save them to GitHub as part of a larger repository as well. And you can find those options under the file menu here, and there's different save as options in here. Alright, so there's a lot more to explore in here. One of the amazing things about Earth Engine and the client libraries that we have is just the sheer depth of it. For example, if I wanted to look at what you can do with an image, I can run this dir that gives me all the properties of like an Earth Engine image object, And if I, scroll back here, and scroll this down here, there's all kinds of different things that you can do with an Earth Engine image object. And each of these are documented in our documentation. They all have different parameters. There's all kinds of different building blocks that we can use in the Python Colab environment, the same that we can do in the Earth Engine code editor, but in JavaScript. All right, so that's all I wanted to do in terms of showing you off what you can do within Colab, just as an introduction. And we'll do more in the future looking at different aspects of Colab and how we can use that to actually run Earth Engine algorithms. In this video, we've really just touched the surface of how Colab and Earth Engine can be used together. To dive deeper into any of the topics that were introduced, explore the links that accompany this video. We'll also be exploring additional features and workflows in future videos. Well, that's all for now. We will look forward to seeing what you create.